Hi everyone. Today we're here to present our assessment for project, a multiplayer shooting game focused on multiplayer polish for our advanced games programming course. This project represents a significant milestone in our games development journey, where we have built a complete multiplayer shooting game framework using Unreal Engine 5.2 and C++. Throughout this presentation, we'll be showcasing multiplayer networking and synchronization implementation, game system refinement and optimization, procedural landscape generation, intelligent AI pathfinding system, and a complete weapon and pickup system. Uh, so without further ado, let's dive into the details. Now let me explain what our tech demo actually is. So at its core, this is a C++ first AI and procedure content generation tech demo. It's designed for a service like authoritative multiplayer environment. Let me break down the key components. So the first, our AI focus. Uh, NPC have intelligent behavior patterns. They prioritize weapon pickup first, then patrol the area. And when they detect a player, they immediately switch to chase and engage mode. And at 50% health or below, they demonstrate tactical retreat behavior and regenerate slowly when out of combat. After healing, they return to their last combat location and actively search for the player. At 0 HP, they die and despawn from the map. And they are smart enough to reload when encountering obstacles to maintain pursuit. And second, our PCG focus, shown in red, is the server randomly generates obstacle at match start using a seeded pipeline. And this ensures deterministic layouts across all clients, maintaining consistency. Finally, our multiplayer principle is the server owns all AI decisions and PCG generation. Key states are replicated to clients for consistent gameplay experience. Here's the live demonstration of our multiplayer synchronization in action. On the left side, you can see client A, and right side, we have client B's perspective. So both views show identical game states. Now let's dive deeper into our AI behavior system, focusing on how our AI, enemy AI, thinks and reacts through its state machine. The AI operates through a clear sequence of states that change logically depending on what's happening in the game world. It begins with the seek weapon state when it has no weapon and needs to find one. Once armed and idle, it switches to the patrol state where it roams around the map. If it detects a player, it immediately then transitions to chase, pursuing the target aggressively. When its health drops below 50% and it's under threat, it moves into the retreat and the regenerate state, backing away from danger and recover health. After it heals and the area becomes safe, it shifts to return and search, resuming the patrol and or investigation behaviors. Finally, when its health reaches 0, it enters the dead state, triggering a despawn sequence. Each of these transitions is controlled by specific conditions. For example, starting without a weapon triggers seek weapon, being armed triggers patrol, detecting a player triggers chase, and so on. When the AI is injured below 50% HP, it retreats and heals. Once fully recovered, it returns back, and if HP hits 0, it despawns. For navigation, our AI relies on intelligent pathfinding and obstacle avoidance. Whenever it encounters an obstacle, it automatically recalculates the route using the nav mesh system or local steering to find a smoother path around the object. This makes the movement appear much more natural and believable, even in complex procedurally generated environments. Uh, Here on the side, you can also see part of the C++ implementation for the flee and hail state. This code handles the state transitions based on the AI's health and whenever a player is nearby, ensuring that our enemy behaves dynamically and reacts appropriately to changing combat situation. Now let's look at how this actually works in game. In this video, you can see the AI navigating through procedurally generated obstacles. Before moving on to the new systems, let's quickly recap assessment 3. In that stage, my main focus was on AI design, and it was the first time I implemented everything primarily in C++ instead of relying on blueprints. The goal was to emphasize utility and functionality rather than visuals, so our design quality focused on purely how useful and logical the system behaved. Some of the key features we built included the healing and retreat logic, which allowed the AI to back off and recover when low on health. The search memory system, which helped it remember previously visited areas and avoid repetitive movement, and a seated object placer that ensured consistent testing environment across procedural generations. This stage was all about laying the foundation for intelligent behaviors, um, making sure the AI could think, react, and navigate on its own in a structured C++-driven way.
PCG Overview, Student B. This part shows my work on procedural content generations. At the start of the match, the server runs a seeded random generator to create obstacles in the map. Each obstacle has a random scale, height, and rotation, but they still follow spacing and line of sight rules. Because the same seed is used, all clients sees exactly the same layout. If a player joins late, the clients use the onRep function to rebuild the obstacle from the replicated data. Here is a short example of the C++ code that handles spawning and scaling of the cover objects. In this video, you can see that the obstacle positions are different each time when the game starts. Assignment 3 recap. In Assignment 3, my topic was procedural content generations, and my design quality focus was utility. I used C++ to create an enemy auto-generation system, where enemies will respond randomly in the scene. However, when I combined my system with my teammates' AI work, the scene became too chaotic and didn't fit well together. So for Assignment 4, I decided to change my PCG system to generate random obstacles instead. This version looks cleaner, runs more smoothly, and works better with the AI system in multiplayer. This slide shows our A4 plans vs implemented Trello board. You can see that we originally wanted to add a UI menu and restart system, but unfortunately we didn't have enough time to finish it. Here we listed what we planned, what we actually implemented, and what we changed during development. The main features we finished include the AI behavior system and the PCG obstacle generations, both integrated into a stable multiplayer environment. Next, this video shows the full demo combining both the AI and PCG systems. Challenges and lessons. Here are some of the challenges we faced and the lessons we learned during the project. At first, we planned to create a simple UI menu, but we ran out of time before finishing it. We also originally planned enemy generation for the PCG system, but it made the scene too chaotic, so we replaced it with obstacle generation instead. For the AI system, we made several adjustments to improve multiplayer stability. We reduced the number of AI actors, simplified the AI's visions and pathfinding, and moved our healing and state control fully to the server for better consistency. This change helps us make the final demo cleaner, more stable, and easier to test in multiplayer.
For assessment 4, our project was divided into individual technical focuses, and I was responsible for the AI system, while Lily handled the procedural generation system. My main task was to design and implement the entire AI logic in C++. This including building like all of the core behaviors such as patrolling, chasing, retreating, and regenerating. I also implemented the AI desks and the spawn system along with state replication to ensure everything worked correctly in multiplayer world. To make the AI movement and the reaction smoother, I spent additional time adjusting its vision detection and pathfinding parameters, improving both responsiveness and stability. Meanwhile, Lily developed the procedural content generation model, also fully in C++. She replaced the old random enemy spawner with a deterministic like obstacle generation system, ensuring more controlled and consistent results. She also implemented the server-side generation and replication so the world would stay synchronized across multiplayer, like multiple clients. Finally, they tuned the spacing and layout rules to make the gameplay area more balanced and readable.